Okay. So we are going over 3.4. We ended off at number 2, so we're just going to continue on. And we'll remind you what we went over as we kind of go, just so that it's a little bit more in the front of your brain. So it says, maybe now you remember some of the different forms of quadratic expressions, factored form and standard form. These forms exist for all polynomials, although as the higher priors get, the algebra may be a little trickier. In standard form, polynomials are written so that the terms are in order, with the highest power term first, and then the lowest, and then the lower powered terms, so that each term is of a lesser power than the previous. So they're standing in height order. That's all they're saying. Okay, when I write this out, I write it in height order. I say x squared, then x to the first, and then this guy is called x to the 0, right? You guys all see him, x to the 0. X to the 0, again, anything to the 0 is 1, as long as that the base is not 0. So this is in height order, from tallest, meaning highest power, to shortest, meaning no x to the 0, right? Okay, very good. Back to this. Okay, here's some examples. Notice they're in height order. 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 Some of them are actually missing someone, and that's okay, right? They're missing people. That's okay. Even this being in height order. Now, you can make a crazy polynomial by adding more and more and more higher powers. All you're doing is you're adding terms, right? It's not any different, but we just like to see it in height order. Okay, so it's when you write something that's not in that order, it's almost like how Yoda talks, right? Where he says bathroom have to go I. Like, everyone understands what you're saying, but it just sounds kind of off. Okay, so hopefully you also remember that you need to be sure that each term in the first factor is multiplied by each term in the second factor, and then like terms are then combined to be to give you standard form. You can use area models, boxes, mnemonics such as FOIL, first, outer, inner, last, to help you organize, or you can just check every single time to be sure that you have all the combinations. It can get more challenging with the higher powered terminals, but polynomials, but the principle is the same because it is based upon the mighty distributive property. So the distributive property basically says everybody in here gets to play with everybody in here. And this box method organizes that for you. So everybody up here, this x got to go, like got to play with x, got to play with -2 to produce this. This 7 also got to play with x and got to play with this, okay, to produce this. And then you just add like terms. So continuing on. So Tia's favorite strategy for multiplying polynomials is to make a box that fits the two factors, like an open area model. She sets it up like this. So here's her method. This is my preferred method because it organizes it, and you won't mess up as long as you fill in all the boxes. As opposed to this method over here, if you forget one of these with one of these, then you won't know because you're not filling in something, right? That's why they give you forms to fill out, because you can tell if you forgot your name, right? You can tell if you forgot your address or your zip code or the area code of your phone number, right? There's boxes already out for you. Here, it's a little bit confusing. So can you take a second and just fill this in and give me standard form, just so that we're all on the same page. Then I'm going to show you Tahani's method, which is this way, and then you could decide which method you like. Now, for me as a teacher, I'm not one of those that says you have to do it this way or you have to do it this way, but just make sure that you understand why your method works. Okay, so go ahead and start with this one, and we'll check with your answers in just a second. Okay, so when you're multiplying these out, all you're doing is you're multiplying, in order to fill in this box, you're going to multiply whoever's here times whoever's here to write the product here. So for this box, it's going to be x times x squared, which you all put as x cubed. I saw your answers. And then I'm just going to go all the way across. So x times -3x, that's -3x squared. And x times 5, which is just 5x. So if you kind of think about it, you're really doing some kind of like 8th grade work right here, because you're really just distributing and you're multiplying. Right here, there's not anything complicated, right? I haven't given you anything that's like, oh my gosh, this is very new, Miss Johnson, right? Okay. So again, multiplying, not new. This is not new. You all with me on this? Technically not new. So then what I'm going to do is I'm going to add like terms. Again, this is still 8th grade stuff. So like terms are going to be anything that have and share the same like x, same base, same power, right? So those two are the same, and these guys are going to be like terms. So I'm going to add those together. Final answer is x cubed minus x squared minus x plus 10. Okay. So there goes my answer. Done. Right? Yes, very good. So someone says, hey, Ms. Johnson, that's a cubic. Very good. There's other things that you can tell from here. So can you drop some stuff in the chat? What else can you tell from standard form while I graph this really quick? What else can you tell from standard form? X to the third minus x squared minus x plus 10. And then I got this guy over here. What else can you tell? Look at this function here. Did you expect it to be up here? Did you expect it to be up here? Someone says, that's interesting. That's a 10. Right? Yeah, exactly. Good job, Noella. So your job as a mathematician goes like this. That's a 10. I wonder if that 10 and that 10 are on purpose. Like that's not a coincidence. And the answer is yeah, it's not a coincidence. And the reason is because this is your y-intercept. Y-intercept means x is equal to 0. So do you see how all these guys get zeroed out? 0 minus 0 minus 0 is 0 plus 10? 10, right? So in standard form, we call this standard form. In standard form, that guy right there is known as your y-intercept, okay? These other numbers here, not so useful. So whenever you see Miss Johnson and she's graphing, standard form, not her favorite. Not her favorite at all, okay? Factored form right here, this is the factored form right here. So let me write that out. It's x plus 2 parentheses x squared minus 3x plus 5. Let me see if I got that right. X plus 2, x squared minus 3x plus 5. What did you guys notice? What happened? What happened when I entered this one? What happened? Yeah, they're the same. Is that important? Is that important that they're the same? Yes. Yes. That's important because you told me that you wanted me to set this up in standard form. This is standard form. This is factored form. And when I put them together, they like go behind each other. They're like playing, hide and seek. Boop, boop, right? So that's really important, especially for those of you who are like really interested in getting an A on our next quiz. Because let's say you do all this work and let's say you just mess up. I don't know, you say 2 times 5, and you add instead of multiply, and you put a 7 here. Then you go over here and you check your answer and you're like, yikes. And this is what it shows. What should this tell you? Let's say you did this and you put a 7 here instead of a 10 and you graph it just to check. What should you do right now? What should you do right now? Yeah, you should fix your answer. Fix my answer. Ms. Johnson, which one is going to be wrong? Well, the problem is not going to be wrong, right? So then I'm going to go back and be like, silly. 2 times 5 is 10, not 7. And I mean, hands up. I make mistakes all the time. If you've been watching Ms. Johnson, she makes mistakes all the time. And sometimes I make mistakes on purpose. Sometimes I don't. Sometimes I just, I really just mess up. Okay, perfect. So number 1, I know how to check my answers. Check, check. Ms. Johnson gets a big old happy face. She's very excited because look, it's all the same. So let's see. They are the same. Let's see. What does this part say? It says, try checking your answer. Graphing polynomial if the graphs are the same, you're correct because they're equivalent. If not, they go back and check your answers. Very good. Okay. Last thing. Now looking at this guy here, Okay, looking at this guy here, is there anything here that tells you about this? Looking at my graph, is there anything that tells you about my graph? There's just one little thing. And it's actually a big thing. It's not a little thing. What do you notice here that could tell you about this here? Anyone see it? I'll give you a clue. It has to do with this 2. Yeah, very good. And what about that 2? I said it at the same time as someone typed it. Awesome. So what about this 2? Does anybody see a 2 anywhere here? Does anybody see a 2? 2, where are you? Yeah, this 2 right here, our x-intercept. Very good. So if you remember, this is back in the day, probably integrated 2. Yeah. Integrated 2. So here's our factor, right? So it goes x plus 2 parentheses x squared minus 3x plus 5 close parentheses equal to 0. If you remember the 0 product property, which we will be revisiting later, right? We will be revisiting later, but it basically said, okay, so let's remember back in 3rd grade, what was your favorite multiplication table? Yeah, it was 0. And the reason why it was 0 is because 0 times anything is 0. And you could teach this to your, like, I don't know, your favorite little cousin, your favorite niece, nephew, whatever. 0 times anything is 0. So no matter what I say, you're going to say 0. Ready? What's 0 times 2? 0. What's 0 times 5? 0. What's 0 times 12? 0. What's 0 times 1,347,562.5? And they'd be like 0. And then everyone thinks, oh my gosh, genius. No worries. Okay, so we have the 0 here and a 0 here. So basically I'm saying one of these guys must be 0. So I just set them equal to 0. X plus 2 equals to 0, and x squared minus 3x plus 5 equals to 0. Here, very obvious, x equals -2. X equals -2, right? Sorry, this guy's in the way. X equals -2 shows up right here. Boom, bam. Right? Let me take a picture of this so that we can like connect everything. So your job again as a mathematician, I don't know where there it is. Your job again as a mathematician is to make these connections that are super important. So what connections do you see? I need to copy this and put it here. What connections did you guys get again? Can you write them for me so I can copy them down and put them on our little thing right here? What connections do you see between the standard form and the graph, or the factored form and the graph? So let me just write this here. This guy is called standard form. This guy is called factored form. Okay. What helped you here for factored form in the graph? How are they connected? Yes, they share points. Very good. So this x plus 2 here is this, oops, I don't know where I'm going here. Is this guy right here. Got it? These two have to do with each other. What else? Yeah, when we graphed, perfect. I'm going to snip that because that's important. They should be the exact same. So someone said when we graphed oops, hold on. When we graph the standard form, here, let's put it right here. When we graph the standard form and the factor form, they're exactly the same. Yes. Yes. Let's put a check next to this. Yes. Okay. And what about the standard form? What was so important here about the standard form? What information can I get from here and graph it here? What was the one? There was only one thing. Very good. Very good. Someone says it moves 10 up, Ms. Johnson. Very good. So I'm just going to take this plus 10 and I'm going to highlight this. Okay. So what I basically am trying to get you to do, because as a mathematician, this is what I want you to do. As a mathematician, you should be able to say, this is how these two things are connected. This is how these two things are connected, right? And then someone else might say, hey, Ms. Johnson, how come you didn't solve this one for 0? Does anybody see why I don't need to solve it for 0? Does anybody see why I don't need to solve it for 0? Kind of. But it more has to do with this. If this number had another 0, it would be graphed here, correct? It would be graphed here. It doesn't have another 0. So that means that this guy doesn't have real solutions. More on that later. Another reminder of that for sure. Where is my Desmos? So here. So remember here, like if I had like, let's just say, turn these off real quick. Let's say we had x plus 2, x minus 4 or something like that. Oops, what the heck did I write? Plus 2. Okay, there it goes. So notice here, right? Everybody see the important thing that I want you to see? What do you see? What do you see here? What do you see? What do you see? How is this connected to this? That's what we always want to ask. How is this related to this? How can you predict this picture using just this equation? Yeah, right? This is that, oh, this is -2, this is -2, this is +4, this is +4, okay? So yeah, we're really talking about our x-intercepts. Very good. Very good. Okay, so I'm just gonna move on because we've been on that. Okay, now number 5. So this is Tahani's method. Is this the same problem? No, this is a different problem. So now what I want you to do is I want you to try this. Now, actually try this method, okay? So we always have this, it's called confirmation bias. Like I show you one thing and you're like, I love this way. And then I show you another way and you're like, I don't like that way. And it has to do with what you experience first. So regardless of, can you please try this way? What do you want me to do here, Ms. Johnson? I want you to distribute this x to the x squared, the x to the 4x, and the x to the -2. Write those terms out. Then I want you to distribute the -3 to all this. Okay, go ahead and get that done.
Miss Johnson.
I was on mute the whole time, wasn't I? Dang it. Okay. I thank you for telling me that I was muted in the chat. I was all on the math part. So, okay. What I was basically saying is when you're doing it this way, one of the things that I've seen to help people understand is I put my finger here and then I go all the way through here so I don't forget anybody. I'm a very forgetful person when it comes to doing these math techniques. So that's why I prefer this way, because look, if one of these boxes is open, empty, it's obvious to me like, hello, you forgot something, like me when I was muted. Thanks for having my back. I think that was you, Skyla. I appreciate it. Okay, so then I just go all the way through, and then I said, hey, watch me here on this part. I just line them up with their partner, right? Whoever like term there are. And a lot of you already got this right, so I'm not really concerned about this. The other way that I've seen other people do it with success is almost like this, and it's very similar to how you multiply 129 times 26, right? You start with 6, you multiply all the way through, and then you go with the 20, and then you multiply all the way through. Here, you're just going to make sure that your place value is set. Here, I'm going to do the same exact thing, except for now I'm just going to line up my like term. So see which way you like best, and then that's the way you should do it. Okay, so I'm just going to do this really quick. -3 times -2, that's 6. And I'm going to put a plus in front of it so I don't forget that it's a plus 6. -3 times 4x is -12x. And then -3 times x squared is -3x squared. And then I'm going to go with x, and I'm just going to line them up wherever they go. So x times -2 is -2x, so that goes under here. So I'm going to put -2x. X times 4x is 4x squared. So I'm going to put a plus out in front. And then x times x squared is x cubed. Thanks, guys, for being patient. And then I would get the same exact answer. The next thing I want you to look at is, how are these two ways related? How are they the same? How are they different? Actually, the 3 ways. Can I make this a tad smaller without you guys going squinty-eyed? Okay. Do you see how x, like this row here would correlate if they were the same problem with like one of these rows, and this row here would correlate with this row, but this row right here, because these are the same exact problem, do you see how this second row is this guy here? Which makes sense because that's the -3 times this, right? And this first row correlates with that, and that makes sense because that's the x times this. So this is one of those things, like, pick your favorite way, right? Choose your own adventure. It doesn't matter because, well, in choose your own adventure, the ending changes. Here, your answer stays exactly the same. It's just which way you prefer. Okay. Hopefully this is giving you some, like, can you tell me in the chat, which way did you prefer best? This is called the box method or the area model. This is called like distribution, and this is like multiplying like your numbers. Which way did you like the best? Okay. Yeah, box method for me, I agree. You guys all said the same thing. And sometimes I have to think, is it because I showed you that way first? Or is that the way that your other teachers have showed you, and that's just the way you prefer? Okay, so for these 3 problems here, I'm going to let you do them on your own, but there's no difference. Choose your favorite method to use. You want to use Tahani's? Do you want to use this other way? Do you want to use this? Do you definitely see how, if you didn't learn this back in like 3rd and 4th grade, do you see how difficult this would be right now? Right? Yeah, this would definitely be difficult because, number 1, you don't know -3 times 4. That was back in 7th grade, right? And then number 2, you just kind of are making sure that that works, right? Give me a second, guys. Okay, so the only last one, I told you this last time, is when we get 3 of these right here. Can you imagine how you multiply 4 times 6 times 2, right? You would multiply 2 of them first, maybe 4 times 6. And then once you got that product, 24, then you would multiply that by 2 to get your final answer. So the same thing goes here. You're going to multiply x plus 2 times x minus 2 first, let's just say. And whatever that is, then you're going to multiply that by x plus 3. So I do want you to try this and see if that makes sense to you. Uh-oh, you got a different answer for all 3 of these methods? So this was a different problem. So you should have gotten a different answer. Oh, wait. Are you talking about these 3 for number 6? Okay, good. Yes, you should have gotten a different answer for all 3 because these are different problems, right? Good. So then I want you to check it using the using like this method where you plug both of them in, and you should get the same exact cubic graph, right? Say, especially for this one, I'd like you to check. Okay, so see if this one makes sense to you. I'm not even gonna have you practice right now just because we're running short on time. So this one here, number 7, it says multiply both of the following expressions using the strategy of your choice, write your answer. Okay, the very first thing that you need to remember is what the heck squared means. What's the definition of squared? What is that definition of squared? Yeah, multiply it by itself that many times, right? Like this one would be x plus 1, x plus 1, x plus 1. Very good. So here, they're really just telling you to do x plus 1 times x plus 1. And now I kicked you back over here to either this strategy, or this strategy, whichever one's your favorite, right? So this one, again, x plus 1 cubed would be the same thing, x plus 1 times x plus 1 times x plus 1, right? So again, you're doing this kind of thing that we just did here, where you're multiplying 2 at a time, and then the third, okay? Again, checking your answer by graphing, always necessary. And then I wanted to show you this really neat triangle, okay? So let me do... let's do this one really quick. I want to split you guys up. If your last name is in the first part of the alphabet from A through M, then you're going to do this one. If your last name starts with N through Z, I need you to do this one. So I'm going to split you guys up so that I can have you do that. And then for those of you who are finished with this one, A through M people, can you also do x plus 1 to the 4th? All right, perfect. So some of you did this one, some of you did this one, and then some of you did this one as well. So I'm gonna build on each one because that's how you multiply them. So x plus 1 quantity squared, you guys already told me is x squared plus 2x plus 1. So I'm just gonna write that down here. And then x, if I multiply this, right, by x plus 1, you guys said that I got x cubed plus 3x squared plus 3x plus 1, right? X cubed plus 3x squared plus 3x plus 1. Okay. I'm going to multiply this one by one more x plus 1 to get me x plus 1 to the 4th, just so that you all will see this, okay? You could do it in 2 ways. You could either multiply x squared plus 2x plus 1 times itself, because that's what x plus 1 quantity to the 4th is. It's x plus 1 quantity squared, right? So I can multiply this by itself, and it would be a huge box. So I think you've never seen a huge box, so I'm going to just draw a huge box and then show you. It doesn't matter. The structure is still the same. You're just using it differently. So this is x squared plus 2x plus 1, x squared plus 2x plus 1, right? So this is a big square. So I'm going after this one. I'm going after x plus 1 quantity squared, right? So it's going to be this. So I know it looks funny, but the structure is exactly the same. So 2x cubed, let me not talk because then I'll mess up. 2x cubed, 4x squared, 2x, oopsie, I messed up, x squared, and then I get 2x and I get 1. So then I'm going to add all these together. So my final answer is going to be x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. Can you guys check my math really quick? I'm 99% sure that I'm correct, but I want to make sure. You guys are always checking my answers. I appreciate that very much. Plus 6x squared plus 4x plus 1. All right, what do you notice in this table? Get your eyeballs and look at what you notice. What do you think I want you to notice here? What do you think I wanted you to notice here? Kind of. But what do you notice between this column and this column? What do you notice between this column and this column. And this will be our last little bit. Yeah, so number one, they grew, right? They grew in number of terms. But another thing I want you to notice is I want you to pay attention to your coefficients. So 1, 1, 1, 1. Now this guy here, his coefficient is 1, correct? Okay, and then I also have 1, 2, 1, and I got 1, 2, 1. And I got 1, 3, 3, 1. I got 1, 3, 3, 1. You guys all see this? And then if I was to write the next row of numbers, what would my numbers be? What would my numbers be? Yeah, 1, 4, 6, 4, 1. Very good. 1, 4, 6, 4, 1. Okay. So that is correct. Now, if I said x plus 1 to the 10th, you would multiply, multiply, multiply out. Well, I have a shortcut for you. So I want to show you this. So this is called Sierpinski's triangle. No, Pascal's triangle. Just kidding. This is Pascal's triangle. Sierpinski's looks different. This is called Pascal's triangle. Pascal was a mathematician a long time ago. And so what I'm going to do is I'm always going to start and end the row with 1. And I'm going to kind of build a triangle. Okay. And so I will always start and end the row by 1. I will always start and end the row by 1. I will always start and end the row by 1. And you're like, okay, Ms. Johnson, you keep saying that. Yeah, I will always start the row and end the row by 1. Now, the way I get these numbers in the middle, here, does anybody see a pattern? How did I get this 2? How did I get this 3? How did I get this 3? How did I get this 4, this 6, and the 4? Anybody see that pattern? Anybody see it? Yeah, you add them. Very good. So the way you get this number here, this guy here, is you look above and you add the guy to the diagonally to the right and diagonally to the left. So then I get 2 because of these guys here. Does that make sense? Now, how would I get this number? Well, I go again. I'd add again and I get 3. And I'd add again and I get 3. You guys all see this? You all see my pattern here? Very good. Okay, so I'm just going to fill this in. So how does this help us, Ms. Johnson? I don't know. So let's say I want you to find me x plus 1 to the 10th. These will be all of your coefficients. Okay, so then here, this would be 5, this would be 10, this would be 10, this would be 5. You guys all see my triangle? Now, if I wanted to the 10th, so this is the 0th row. This is the first row, 2nd, 3rd, 4th. This is to the 5th. See this x plus 1 to the 5th that we didn't fill in here? I could just write it like this. Wait, like what, Ms. Johnson? Watch. X plus 1 to the 5th. And I promise this is the last thing because I'm a minute over now. So I'm going to write my numbers 1, 5, 10, 10, 5, 1. You guys all see that? So what I'm going to do is I'm going to start with 1 and start with the highest power, which is going to be x to the 5th. And then I'm going to write x to the 4th, x to the 3rd. Uh-oh, I'm running out of room. X squared, and then x, and then my constant. But now I'm going to take all my coefficients from here, and I'm going to put them as my coefficients. So 1, 5, 10, 10, 5, 5, and 1. So this is how this helps us. And this is where we're going to pause. You are able to do your exit ticket. Let me just make sure. Yes, you're able to do, I think you were able to do the first part of the exit ticket before. And now you can do both parts of the exit ticket. If you did the first part and you're done, good. If you did the second part, I'm going to count them as 2 separate exit tickets. So get in there and make sure you do a video. If you want to do one video for both, that's fine. You can also do all of the ready, all of the set now. All of the set is now available to you, and all of the go. Really good job. Thank you so much for your work today.